Hello everyone. I am Kumar Bhagavatula, the Interim Dean of the College of Engineering. I'm also a professor of electrical and computer engineering. Welcome to the College of Engineering's webinar series, Faculty Insights, a 20-minute briefing. Thank you for being here today. In this virtual series, faculty from across the College of Engineering share insights into their research, its impact, and provide perspective for the future. Following each 20-minute presentation, attendees will have an opportunity to direct questions and comments to the speaker. Our speaker today, Chris McComb, Gerard G. Elia Associate Professor of Mechanical Engineering, will give a presentation entitled Design at the Human AI Frontier. During this program, he will discuss how AI is rapidly reshaping how engineers imagine, evaluate, and build solutions. Chris will share examples from engineering and design showing where AI acts as a tool, a coach, and even as a collaborator, and what that means for our work as human beings. Together, we will consider what should change, what must be preserved, and the research directions that will keep humans at the center of design. Prior to joining CMU, Chris was on the faculty at Penn State, where he also directed the Center for Research in Design and Innovation. Chris earned dual bachelor's degrees in civil and mechanical engineering from California State University, Fresno, and later returned to Carnegie Mellon as an NSF graduate research fellow, where he completed his master's and PhD in mechanical engineering. His research looks at how people and technology work together in design, spanning human social systems, machine learning for engineering, human AI collaboration, and STEM education, with support from NSF, DARPA, and industry partners. Before I turn the screen over to him, I would like to remind our audience to please use the Q&A feature at the bottom of your screen to submit your questions to Chris regarding his presentation. You may do that at any point during the program. Nikki Bernardi, Senior Director of Development in the College of Engineering, will be moderating the question and answer session with Chris at the conclusion of his presentation. So now, Chris, thank you for being here today. Over to you.
Thank you very much, Kumar. I'm very excited to speak to this group of alumni. As an alum of the university myself, it's always special when I get to speak to this group. So here at CMU, I have the pleasure of leading my lab, the Design Research Collective, as well as a group of faculty that are interdisciplinary and international who focus on exactly this question of how humans and AI should work together most effectively and most beneficially to advance design. I think it's no secret to many of us that AI is expected to be huge in the future. This is one estimate that pegs the amount of economic activity at about $13 trillion by 2030. Some estimates are even higher than this. When we start to look at what this looks like across time, we see a pretty consistent rise, and we can actually break this apart into contributions to different outcomes from AI. And this estimate by PricewaterhouseCoopers says that the largest impact should actually come from improvements to labor productivity. If we look at this another way and expand this across the globe, we can try to make some predictions about where the impact is going to occur the most. I think what we're seeing today is that most of the impact is going to be centered in the global north, which makes CMU's work with CMU Africa that much more important. But we can also start to look at this at more of a corporate or business by business level. And this plot shows the percentage of organizations in this survey that were using either AI in at least one business function, or more recently, a specific survey for Gen AI use in at least one business function. And these are getting pretty high. So 70 and 80% of organizations are using AI in at least some way. So increasingly, AI is everywhere. The flip side of that, though, is that people are also everywhere. People are core to how work gets done, right? We know from the literature and also from our experiences that teams are really common in industry, right? When you're solving hard problems that require lots of different heterogeneous skill sets, you bring the right teams together to solve it. We also know that more than 50% of patents have more than one inventor, and more than 80% of science and engineering articles have more than one author. So all of this points to the fact that teamwork is really core to the way that we live and work, create innovation, and create new science. So the organization at CMU that really brings these questions together, questions of AI, humanity, work, and design, is the Human AI Design Initiative. And we bring together faculty from across campus, drawing heavily from the College of Engineering, the Tepper School of Business, and the Human Computer Interaction Institute in the School of Computer Science. And we pursue two complementary objectives through this initiative. The first is to research and develop novel AI agents. And the second is to get those agents into people's hands and start to understand how working with AI impacts the way that humans think and learn and design. The way that we've started to idealize the space of possibilities when it comes to human AI teaming is through this matrix. And we have a 2x2 matrix. On the left side, we have problem focused versus process focused. We can think about different human AI collaborative contexts where we might want more of a focus on the problem at hand. So can I have an AI that's going to give me a recommended bracket design or recommend a solution for me? And we contrast that to process-focused AI, where process-focused AI is going to help you arrive at a solution by guiding your overall process, nudging you, prompting you. Across the top, we distinguish between reactive and proactive applications. Reactive being a tool that you use, press a button and get a result. Proactive being a tool that might actually ask you to do something. And within this matrix, we have AI as analytics, AI as tool, as partner, and as coach. And I'll show a quick example from each of these to give you a taste for some of the work that we're doing. In AI analytics, this really starts to look like digital twins of human behavior. So a digital twin is a computer representation of a system that often provides some degree of simulation capability. So we've used artificial intelligence to create simulations of product design teams and engineering teams so that we can better understand the interactions between humans on those teams. We've also applied some of these techniques to look at community resilience, and specifically there, we're looking at Arctic community resilience in the face of climate change. More recently, in collaboration with Catherine Flanagan from Civil Engineering and supported by the Manufacturing Futures Institute here at CMU, we had the chance to start looking at human behavior in advanced manufacturing. And the idea here is that we should be able to build a digital twin that helps us understand standard operating procedure, but also look for departures from that standard operating procedure that might be detrimental to safety. Those are just a couple of examples of AI as analytics. In this human AI teaming context, we're often focused on, can we create simulations of the human component? Another area where we've been doing a lot of work is AI as tool. And this is where a lot of really exciting research is coming out from across the college and across the university. The case that I'd like to show you is something called super resolution. So if you have watched like a CSI drama or like a crime scene investigation show recently, they almost always have a grainy photo of the killer and then they hit the enhance button and it gets crisp and bright and everything, right? You can see exactly what their identity is. You can do something pretty close to that using modern machine learning if you know something like the distribution over the data that you're working with. So typically we start off low resolution image. We can do naive upsampling where we just double all of the pixels. That gives us a grainy image that's larger in size. If we use machine learning super resolution, we can get a little more detail And the idea is that this should eventually converge to the real high resolution, real life image. And what we're doing here is applying exactly this idea to engineering simulations. So here we see engineering simulations of fluid flow around a cylinder. On the left side, we have an example of a low resolution mesh. So if we calculate using this mesh, we'll get some approximate solutions. And then we have a high resolution simulation that's really a ground truth. And we can map between these using machine learning techniques in a variety of different contexts and situations very rapidly. So we can start off with a low resolution simulation that runs quickly. We can apply our machine learning algorithm on top of that, which also runs quickly. And all of that takes place before we have time to run the true high resolution simulation. Recently, we had an opportunity to apply this technique to a large aerospace component. So when people are working with this component in their day jobs, they simulate this with close to 1 million nodes. So this is a really complex mesh and a really great test case for some of the super resolution that we're looking at. And I want to show specifically what happens at this region, because this necking feature causes some really interesting physics. So that's what is shown here on the left side of the screen. So we have our low resolution simulation, right? Very quick, but very dirty. And then on the bottom, we have the high resolution simulation, right? It takes a lot more time, but really gets us good accuracy. In the middle, we have our super resolved prediction, which takes as input this low resolution simulation. So what this means is that we can run a low resolution simulation in about 70 seconds and then apply our algorithm on top of it for about another 50 seconds. And if we were to run the ground truth high resolution simulation, that would take almost 700 seconds. So this process enables us to save a fair amount of time and allow engineers to get back to doing the design and iterate more quickly. So those are a couple of examples on the reactive side of this human AI teaming matrix. Next, we're going to come over to the proactive side. So this is where you have a system that might act a little bit more like a partner and might ask you to do things or might be more collaborative. And the last few years, especially with language models, have gotten very exciting on the proactive side of this matrix. So when it comes to AI partners, we have so much opportunity for creating deeply collaborative partners through language models. One area that we've been looking at doing this in is material selection. So often in design, we start out early on and focus on geometry of a product, and material selection, or figuring out the actual material that we're going to use to create something, is often a later consideration. And this can cause some issues. So the goal in working with Autodesk here was to enable engineers to do material first design. And we thought that one way to do that would be to expose an agent that can make material recommendations. And we essentially had this agent scoring different material options and then selecting the highest score. And we compared these scores to actual human engineers. So we fielded a survey that allowed us to estimate how engineers do these material selection decisions as well. And when we compare different LLM approaches versus the results that we get from human engineers, they're different in nuanced and fascinating ways. There is, I would say, some central tendency towards alignment, but one of the biggest divergences is actually when we score titanium for its applicability to different contexts. The red bar here is from our human survey, and the other three bars are from different language models. And I think this illustrates that our language models have some really deeply seated material preferences and biases, because in this case, titanium is overrepresented in their training data. Another area that we're looking at when it comes to language models is trying to identify ways to prompt AI assistants to show elements of human cognition so that we can better bring them into human organizations. And here we're looking specifically at something called cognitive style, which describes how people approach and solve problems. So this is normally distributed. I am an 87 in terms of my score, so I'm about right here. So I fall on the adaptive side of the spectrum. So as you get further out, you prefer more structure and you prefer doing better, so optimizing things. On the other side, the innovative side, as you get further out on that end, you tend to prefer less structure and you tend to prefer doing things differently. And this holds a lot of implications for how we work together in organizations. It holds a lot of implications for how we identify novelty and how we make incremental versus radical innovation. So this is an important factor that we should consider when we create AI agents. If we can tune them across the spectrum, we'll create better AI. And we developed a prompt that essentially allows us to do just that. So this prompt is about 500 words, just an abbreviated version shown here. But when we feed this prompt to a language model and then ask it to come up with solutions, it follows almost exactly the trend that we would expect from human engineers and decision makers. So human engineers, when they are more adaptive, tend to prioritize solutions that have a higher degree of feasibility. So they want to find something that's going to work. And when we compare our innovatively prompted or adaptively prompted language model, that's exactly the difference that we see. On the other side, we often know that innovators will give us paradigm breaking solutions, things that don't look at all like what we have today, whereas adapters tend to give us more paradigm preserving solutions. And again, that's exactly the switch that we see. So that's an example of some of our work in this AI as partner domain. Moving into the last area, AI as coach. This has been some of the most exciting work I've had a chance to do, and also some of the most rewarding collaboration with John Kagan here at CMU. So the idea here is when engineers do complex work, right? So this is an example of last mile logistics. We might design drones, need to route them around town, and then figure out how to get packages from point A to point B. When we have these really complex contexts, it can be valuable to have a facilitator or a coach as part of the team. And the idea is that they can help the team to optimize their processes and work more efficiently. So something a little bit like a Scrum Master. And we implemented a representative AI coach that we designed to work much like a human coach and evaluated it with more than 200 engineering students who we placed on teams. And they were doing this last mile logistics drone-based task. So we had a few people who were in a design role. So we had them designing the drones. We had a few people in an operations role. So they were figuring out how to route the drones around town. And we had one person in a problem manager role. So their task was really to make sure that the team turned a profit at the end of the day. We went through two problems to try to get a sense for the robustness of this coaching strategy. So the first problem was business as usual, delivering Grubhub and Amazon boxes. Problem two was, okay, COVID has happened. Now we need to switch to delivering PPE. And this slightly changed the problem context. What we end up seeing, so our primary metric for success is the amount of profit that was turned by these teams during the exercise. And we compared an AI coach team to a human coached team. Our AI coach went through a process that's shown here. So our AI coach took in all of the action and communication happening within the team, compared that to prior data that shows what a good team should look like, and then uses that to identify a variety of interventions to give to the team. One thing I want to note is for our human coach, they received the same information. So they got all the action, communication data, and they were able to use exactly the same set of interventions to give guidance to the team. So we wanted to make this a one-to-one comparison as much as possible. And when we compare the profit that these teams were able to generate, we end up seeing that our human coach teams are almost indistinguishable from our AI coach teams. And in fact, the AI coach teams might be doing a little bit better. However, one of the biggest drawbacks from this work was that we were using this prior data, right? We were relying on that prior data to give good guidance to future teams. So to get away from that, we've started to look at whether we can use established cognitive constructs to help us guide teams without a reliance on prior data. Specifically here, we're using something called collective intelligence, which is highly correlated to social sensitivity, which we can measure about people, coordinated attention that we can track in real time, and equality of participation, which is another metric we can track in real time. So we took this inspiration to design a new AI coach that takes this collective intelligence into context, and we evaluated it on a new problem. So this is a task that we use pretty often in engineering design that has people design a peanut sheller that needs to have a throughput of, I think it's 100 kilograms an hour. And what we're looking for from these teams is a representative conceptual diagram for how they would structure a machine. And here we weren't able to do quantitative evaluation. So we had some expert engineers rate the solutions as either poor, acceptable, or excellent. And when we compare our AI versus human coached teams, we see a significant shift in the quality of solutions. So we have almost twice as many excellent solutions from our AI facilitated teams as our human facilitated teams. We also end up seeing a progressive fall off over the experiment in terms of the number of nudges or the number of interventions that are necessary. So what this tells us is that people are also learning from these interventions over time. So that is the last piece of this matrix, and the sort of top level big take home that I want you to have from this quad chart is different types of human AI collaboration present different benefits, but also different failures. So it's really on us as designers and engineers to learn about these different interaction modalities and adapt accordingly. Of course, there's the elephant in the room, which is replacement. So what if computers can do so much, right? If they can do all of this and even more in the future, what's going to be left for human designers, right? What are we going to have to do with design, if anything? I tend to think that design is a deeply human process and that we will have a spot. But I like to think about potential futures and the way that we're designing for these potential futures. So potential future number one is that, yeah, maybe AI is going to take over the later stages of design and humans will end up doing the early stages. And we already see a little bit of this, right? Automation and AI are much more common in supply chain, manufacturing, detailed design, and a little bit less common in problem finding and problem framing. So this might be one way that the split ends. Another potential future is that maybe humans will end up doing the physical parts of design. We have these amazing end effectors called hands that are extremely valuable from a robotics perspective because doing dexterous manipulation is a big challenge in robotics. So maybe AI will end up doing more of the cognitive thought work and will be relegated to a role as hands. Not the best future. Another possibility is, in a post-scarcity future, maybe we'll get to do whatever we enjoy the most when it comes to design, right? In a future where we don't have to worry about income, beautiful future to think about, but maybe we just get to do what we enjoy in design. And the last potential future, and the one that I personally think is what we should be driving towards, is that humans will end up doing the most human parts of design. There are still things that we beat algorithms at and will for decades, if not centuries to come. We are experts in empathy. We're experts in relating to our fellow humans at a deep level, understanding their needs, understanding their wants, understanding how to help them, right? We're masters of empathy. We're also masters of insight in a lot of cases. So the potential future that I want to bring about for design is one where humans get to focus on the most human parts of design, where we relate to each other and collaborate. So this work that I shared today was only possible because of some excellent funding organizations and also a phenomenal team of PhD students who I've been privileged to work with over my career. So without further ado, thank you so much for tuning in today, and I'd be happy to take any questions that you have.
Thank you so much, Chris. We really appreciate all of these great insights that you've shared with us today. We will now turn to our audience for questions. As a reminder, please submit your questions via the Q&A feature at the bottom of the screen. Make sure to include your name with your question as well. Let me start off with this first question. Where should we draw the line between human judgment and AI automation and engineering design?
Yeah, so that's a great question. It's an open question for a few reasons. People's perceptions of AI support is changing rapidly. I want to give a shout out to another CMU alum, Leah Chong, who's doing some amazing work in this area, where she tries to track how people's perceptions of AI design support are changing. So it's a moving target. Initially, I was very much of the mind that, yeah, people are going to do early stage design and then hand things off to an algorithm, right? We'll figure out how to frame this, how to pose the problem in such a way that it's solvable, and then hand off. Starting to see some work that is, coming a little bit into problem framing. So I'm thinking more that the line to draw is things that have to do with empathy, right? Things that have to do with deeply human aspects of the job are probably things that we should hold for ourselves and make sure that we don't automate. On one hand, I like to say we automated the wrong things, right? We automated drawings and writing, which are like two of the most fun arts to practice, right? But they're the first things that we ended up automating because we had lots of data. So I'm a proponent for keeping human things for humans.
That's great. Thank you, Chris. Here's a great question. What do you say to people who are afraid that AI will take over everything?
Yeah. The kind of joking response is like, stop hitting yourself, right? It's kind of hard to make that case to humanity writ large. Like we are the people who are making AI. And it's challenging to make the case to your CEO that we shouldn't be making this AI because it has these alternatives that are going to automate everything and take over. So sorry, I got a little bit off track. But anyway, so people who are afraid of this case, I think it's a well-founded fear in some cases, right? Um, I think we should be thinking about how we retain people in jobs where they have deep expertise and how we empower them to use AI to make better use of that expertise, right? So, how can we upskill people, right? That's really the question. I tell people they should be trying to, make up the cost of AI in volume and in quality, right? As opposed to minimizing offshoring, et cetera. Another open question, though.
For sure. This question is from Lee Spence. The thing that he worries the most with AI is hallucinations.
Yeah.
How do you account for them in your research?
That's a great question. So we have started to do a lot more, I would call them hybrid systems. So a system that uses AI for some piece, but also uses deterministic known good calculations for another piece, right? So one pattern that we see a lot is agentic AI, and we might have tool using agents, right? So an agent that calls a finite element analysis code instead of guessing at what the strength of a part is, right? So that helps to ground AI into the real world a little bit more because as engineers, we know the physics, right? However, hallucinations are still an issue. It comes down to, in my mind, a systems engineering challenge. So AI systems are usually one small AI piece and a lot of autonomy wrapped around it. So if we can use all of that autonomy in a good way, we should be able to catch hallucinations and then try to mitigate them. So yeah, to sum up, I would say we should wrap these hallucinating systems in a nice, comfortable computer science blanket that's going to help to reduce those hallucinations.
Wonderful. Thank you. So this question is from Peter. Have you seen the MIT analysis that AI has a negative impact on productivity? There are some other reports along these lines. What is causing this?
Yeah, so I think in most cases it is a sort of cognitive fallacy or a cognitive shortcut that people fall into, right? In some cases, when you have a very proficient tool, that turns off parts of your brain, right? And you're thinking less critically about the work that you're doing, the work that you need to do, the goals that you have, right? And you get tied up a little bit more in correcting the AI slop that comes out, right? So I haven't read the study in detail, but that's sort of my hunch, and based on some of my own personal AI use, I think that's probably what people are running into. One of the, as opposed to tech debt, right? So we often refer to tech debt in technical systems that have been around for a long time as something that accrues through decisions that you've made, right? You might end up using legacy code and things like that. The term that I've heard more recently when it comes to AI-supported software development is cognitive debt. So you're using this AI assistant to create some large, complex project. And if you were doing that yourself, you would be building an understanding and a mental model for that project as you go. But where I've seen people fall into lots of trouble is this cognitive debt, right? So I've used AI to build this huge system, and now I don't even know it enough to debug it.
Thank you. So there's a question here from Keith. How close were the results of the fast super resolution analysis compared to the much slower high resolution analysis? He commented that they superficially looked quite close.
Yeah, so they are quite close, which is pretty exciting. So to share a little bit more about that project. So amazing PhD student Wenzhou Xu co-advised with Noelia Grande Gutierrez, who does a lot of work looking at biological flows in the body. And the way that we wanted to approach this wasn't purely AI or purely machine learning, because we know a lot of stuff from simulation science and numerical methods already, right? So we wanted to take this hybrid approach. And what my student was able to do is create a neural network structure and architecture that emulates characteristics of a Taylor series expansion, which is something that's really core to numerical methods. So we actually are able to make a few claims about like error reduction in the application of the algorithm. Where we have seen issues is when you have like complex flow regimes that aren't simply left to right or cavity flow, right? So if you end up having turbulence, right? If you end up having like a recirculating flow, like those become more challenging to predict. And we've extended the work a little bit to address that. But yeah, this is sort of the challenge with CFD machine learning, right? Is it tends to look pretty good on the surface, but the challenges and the issues start to emerge when you start to look at physics guarantees. But those are things that we baked in from the beginning.
Great. Another question here from Serdar. Any comments on possible loss of economic activity due to AI potentially eliminating jobs, reducing consumer spending, etc.? He mentioned that this question is related to your first slide with the projected 13 trillion increase in AI-driven economic activity.
Yeah, this is a great question, and I have some concerns about this. Large model providers own sort of the means of production, right? They own a lot of the compute. So I think in most cases they stand to benefit from the economic activity, right? I do have some concerns about our ability to sort of train the next generation of engineers and computer scientists. There's this great question of, AI is great for supporting senior developers, right? Because they know how to do the job already, but AI sort of reduces the capability and the learning opportunity for junior developers. So I think in addition to the thinking that we're doing at the university in how to bring AI into education in a way that makes sense, that supports people, that helps them learn, I hope that we can get some of those same insights out into industry for how to bring up younger engineers.
So I think this next question is closely related to this. What advice would you give to college graduates who maybe don't have enough expertise yet while they're in the job search or looking for jobs?
Yeah, that's a great question. So there's sort of two ways to answer this, right? There's the job searcher who's interested in AI explicitly, and the job searcher who is searching generally, right? So for somebody who's searching generally for jobs, I think it's increasingly important to have AI familiarity and a degree of AI literacy, right? Not a degree in, but some level of AI literacy, right? So for I would say just about any worker who's entering the job force, like knowing some tips and tricks for how to use like a ChatGPT or a Gemini is going to be pretty important. One of the sayings I've heard thrown around is like the people who, or AI isn't going to replace the people who know how to use AI. It's going to replace people who don't. So I think there's a little bit of truth to that, right? So upskilling some baseline of knowledge, I think is valuable for everybody. For people who want to go to work in AI and maybe don't have quite enough expertise yet, I think there are lots of really good open courses in AI and machine learning that they might be able to upskill on. There are also lots of available certificate programs that might help them increase their expertise while they look around to find that job.
That's great. Okay, this question is from Rudolph. On your point about empathy, it feels like there's a conscious effort on part of the models to relate more and more with the human. What is some of the good research on this topic?
Yeah, good question. So yeah, I mean, it's almost a dark pattern that's emerging, right? Like some of these AI agents are now optimized for engagement, right? They're optimized to keep you chatting and keep you talking, which echoes some of what we've seen from social media. I have a lot of respect for the work that the Hugging Face team is doing. So they're a startup in France, I believe, late stage startup at this point. But they have a lot of their software is designed from, it's like a calm computer paradigm or something like that. So it's very much human-centered, and it's trying to help extract people a little bit from the tight interaction loop, right? Can't recall any researchers' names off the top of my head. Another related area of research that's really interesting is the degree to which language models can proxy people during user research, right? So this is something I see a lot of students try right off the bat. Like, oh, you told me I have to go interview 3 people. Let me fire up ChatGPT, see if I can interview ChatGPT in the same way. There's some research that says that there's some value to that, right? With the immense amount of training data that goes into these models, like there's some representation of a person that's valid in there, right? But the question is, what kind of person? Probably somebody who looks a lot like me, right? So there have been examples where like the Llama model or a previous version of Llama, if you asked it to come up with a user persona, would never imagine somebody living in China, right? So that's just one example of some of the limitations in these models as we start to learn or start to use them for empathy. Another downside for models, and like I would say a huge upside for people, is often when we do human-centered design, we might do something called ethnography, which is a technique from anthropology, actually, right? Where you deeply embed with people, work with them, live with them, understand what they're doing. And that's something that is fundamentally accessible to people in a lot of circumstances that are not represented on the internet, right? So there are cases where we have the agency to show up as a physical body, right? Take part in work, understand the empathy, understand the needs that people have that will never be accessible to a language model.
Right. Here's another question from Keith. He said that he's read the training with he has read that training with a large number of sample examples, makes the decision making of an LLM better, But if the number of examples is very large, the results start declining. Why would that be?
Oh, that's an interesting question. I might not be the person to give you a crisp answer to that question, because I tend to not train language models from scratch. Um, there might be some trade-off with like model size and the number of tunable parameters, where like if you're trying to learn too much data, it just becomes like a little muddled, right? And you maybe need either a larger model or to like segment the data. But I'm not too sure about that case.
Okay. Here's a good question. How have federal funding issues affected your work? Is the increase in interest in AI leading to more research funding?
Yeah, that's great. There's been a bit of a shift, right? So maybe philosophically, I think that probably the equilibrium that we'll hit is maybe a little less direct funding to universities from the federal government and maybe a little bit more, subcontracting from industry, right? So I think the ultimate result of this shift is probably going to be closer academic relationship to industry, which I think is honestly a good thing. I'm kind of excited to see a little bit of that shift in academia, because that brings us closer to use cases. It brings us closer to needs, right? The NSF has been using this term of use-inspired research, right? Which is sort of human-centered design and empathy and ethnography and, be deeply versed in the problems that you're solving. So because of some of the shifts in the funding domain, I think, people who are interested in design, human-centered empathy, are pretty well situated to succeed in sort of the new normal.
Great, thank you. This question is from Carl. The main goal of any process is to balance technical, cost, and schedule. How is this accounted for in AI?
Yeah, so the term that I learned as an undergrad was you have to make all of your designs otobos, right? So on time, on budget, and on spec. So those still come into play in a big way when we talk about AI. So there's usually a really interesting trade-off around model size, your hardware, and the timeliness of what you're doing, right? So how quick can you get a response? What hardware do you have? So when we engineer new AI systems, I mean, that engineering is engineering, right? Those three don't go away. I think maybe where we're starting to see some of that break down is a lot of the hype around AI drives so much funding that being on budget becomes maybe a little less of a consideration for some of these startups, right? And they get to chase capabilities, which is kind of exciting. But from more of an engineering perspective, if we're building products, if we're using AI to do things, I think on time, on budget, and on spec haven't gone anywhere. Those are still essential. One of the things that gives me a little pause for AI is, coming back to the point on hallucinations. We haven't yet started to think about AI and language models in the same way that we think about engineering tools, right? So in engineering tools, we place such a premium on accuracy, right? On knowing the uncertainty in those tools. And I think we need to start addressing language models and AI tools in much the same way, right? So looking at them with a very hard eye to certainty and uncertainty.
All right, we have a few more questions here.
Great questions.
Yeah, they're very good questions. Thank you, everyone. So this question is from Prasad. And first he commented that he liked the coaching examples a lot because they focused on team effectiveness rather than individual productivity alone. Do you have any additional color or beliefs on how AI can help with better group decisions in organizations and in society?
So I think humans, we do an okay job of making decisions, right? Where we get really messed up is when we get emotional, when we bring ego into it, right? When we start to do a little too much type 1 reasoning and not enough type 2, or vice versa. I can never get those straight. So it really becomes, I think, where we need help is in contexts where cognitive biases become more likely, right? So these are contexts when we're placed under decision pressure in some way, whether that's time pressure, whether that's social pressure, right? These are sort of fraught situations where I think that AI support can go a long way towards helping us as decision makers make better decisions by, in some cases, just prompting our reasoning. So some great work in human-computer interaction by Nick Martellero that's looking at essentially Socratic AI agents that only ask you questions. They don't give you any answers, right? But just asking the questions can still go a long way.
Great. And then it looks like we have one final question. How are undergraduate students involved in the research happening in this area at CMU?
Yeah, so actually one of the best papers that came out of my lab this past year was a conference paper by Megan Ying, who is an undergraduate in mechanical engineering at CMU. So she, over the course of her senior year, developed an AI agent that's capable of taking in a new design problem, searching the internet, and finding exactly the right material to use. There are lots of different ways for undergraduates to get involved. We have summer undergraduate research apprenticeships, research fellowships, and then there are also lots of opportunities for students to get involved during the semester, either as a work position or for units and credits to become involved with the research. So any way possible. There's lots of work to do, and it's going to take all of us.
Yeah. Yeah, I know, particularly in the College of Engineering, undergraduate students have the opportunity to do a lot of research. So.
Yeah, I can speak specifically to mechanical engineering. I think the statistics are probably similar across the college, but in mechanical engineering, it's something like 80% of our undergraduates are involved with research at some point.
That's wonderful. And one last question came in, so I wanted to make sure to ask you this. So this is from John, and he said, hasn't every claim that humans are unique in some way been disproven? Are we on the path to ascending to silicon-based life forms? I really hope not.
This is a really good question. And this is the one that keeps me up at night, right? I think I have beliefs and hopes about our unique ability to empathize. I think that's pretty core to what makes us human and what makes the human experience interesting. But yeah, it's probably a question of what do we like about design, right? What do we like about being involved with design? And if that brings value, right, then yeah, clearly that's a place where people should be involved, right? But also if it brings enjoyment, I think there's value in keeping enjoyable things around. So when it comes to replacement, when it comes to AI getting better and better and better, I think we might need to start shifting from what do we need and where are humans exceptional, more towards what do we enjoy and how do we protect the things that bring us joy and happiness.
Great. I love that answer. Thank you again, Chris, for a very thought-provoking and informative program. I would also like to thank our audience for participating today. I hope you will be able to join us at future Faculty Insights programs. Please keep an eye out for a follow-up email soon, which will include a link to the recording from this session. Thank you again and have a great day.